All right, folks. In this video, we're going to talk about how we balance chemical equations. As chemists, our main work is doing chemical reactions, and we synthesize new compounds, explore the chemical properties of the new compounds, like catalytic properties, for instance. So, how do we present those chemical reactions to general audience or a chemical community? Well, one way to do this is writing chemical equations. Okay, let's use a very simple chemical reaction to explain this. Well, natural gas, methane, CH4, is the main component of natural gas. When you use the methane to react with the oxygen, you have two products, carbon dioxide and water. These two products can be characterized by chemical methods, so we know their presence for sure. Okay, so if you present this chemical reaction like this, CH4 plus oxygen to generate CO2, which is also a gas. I'll talk about this letters in the parentheses in a moment. Products, water. Okay, if you write this chemical reaction by using this equation, then you will realize some problems. For instance, well, you have 4 hydrogens on your left side. The chemicals on your left side in the chemical reaction are called chemical reactants. Okay, so these two are reactants. And the compounds on your right side, okay, right side of the arrow, we call them products. Okay, you have 4 hydrogens on the reactant side, and you only have 2 hydrogens on the product side. So if you write the chemical equation like this, then it looks like you start with 4 hydrogens and you end up with only 2 hydrogens, and the other 2 hydrogens just vanish, just disappear like a magic. That's not going to happen because it's against the conservation of mass. Okay, you cannot create the mass from nowhere, and you cannot just make a mass disappear. Same thing for oxygen. You have 2 oxygen atoms on the reactant side, and you have total 3 oxygen atoms on the product side, 2 here and 1 here. And again, you only have 2. Where does that third oxygen atom come from? You cannot create an atom from nowhere. Okay. Again, this is against the conservation of mass. This is a basic law in the physical world we are living in. Okay. So looks like that we should make sure that the atoms on 2 sides should be equal to each other. In other words, we need to make sure this equation is balanced. Okay. Here, I'm going to just show you the balanced equation directly. We'll do some practice in a moment. But I want you to compare these two equations. This is unbalanced equation, and this is a balanced equation. You can see that difference for each compound is, well, here you still have CH4 and CH4. For here, you have 1 O2 in the top equation, but you have 2 O2 in this balanced equation. Now, if you visit the oxygen, you have a total 4 oxygen atoms. Well, remember, you have 2 oxygen atoms in 1 oxygen molecule, and you have 2 O2 molecules, so total you have 4. 2 times 2, you have total 4 oxygen atoms. Now, on the product side, this is still CO2, remaining the same, but H2O, water, you have 2 in front of water. What does that mean? It means that you have 4 oxygens on the reactant side, and now you have 2 oxygen here and 2 oxygens from 2 water molecules. So 2 oxygen atoms on the reactant side, 2 oxygen atoms on the product side. So oxygen is balanced. Now, how about hydrogen? Remember, now you have 4 hydrogens on the reactant side, and you have 2 water molecules on the product side, and each water molecule has 2 hydrogen atoms, so 2 times 2, you have 4 hydrogens on the product side. So hydrogen is balanced. Okay. Now how about carbon? You have 1 carbon on the reactant side, you have 1 carbon on the product side. Therefore, carbon is also balanced. Okay, so the full equation is balanced equation. Okay, now this is not against the conservation of mass. Okay, so everything is perfect now. Okay, so this is the from unbalanced equation to balanced equation. Now let's talk about the letters inside the parentheses. Okay, so these letters represent the states of those chemicals, okay, or molecules. Well, I'm gonna write it here. G represents gas, okay, and L represents liquid. Okay, we don't have L in this equation, but we'll see L in the next slide. Now S represent solid, okay, and AQ represents aqueous solution. Okay, so in other words, when we present the chemical reaction through chemical equations, we need to show what states of those chemicals or compounds, okay, or molecules, because the states could be some very important information for us to do thermodynamics, which will be covered in the following chapters. Okay, so we do need to know how we present the states. The second thing is those numbers in front of each formula. Okay, well, you can see that those numbers, they are integers. Okay, they are integers. Those integers reflect the chemical reaction ratio for those chemicals. In other words, in this reaction you have 1 CH4 molecule react with 2 O2 molecule, and that will generate 1 CO2 molecule and 2 H2O molecules. Okay, or you can see that 1 equivalent of CH4 can react with 2 equivalent of O2, generate 1 equivalent of CO2 and 2 equivalent of H2O. Or you can see that 1 mole of the CH4 can react with 2 mole of O2 to generate 1 mole of CO2 and 2 mole of water molecules. Okay, so you can see the molar ratio or chemical ratio or equivalency for regarding those the integers. Okay, so we call them coefficients. Okay, they have to be integers. Another thing that I want to remind you here is those integers, they have to be positive, the smallest positive integer for those compound. In other words, if you write the equation like this, if you say, okay, I have 2 CH4 molecules react with 4 O2 molecules, I generate 2 carbon dioxide molecules and 4 H2O molecules. Well, if you check the number of those atoms, they are balanced, okay? But if you check those coefficients, the numbers in front of each compound, then you see that they are not the smallest integer. Okay, all of them can be divided by 2 to get 1, 2, 1, 2. Okay, so in order to be as simple as possible, we will use the smallest positive integer ratio for those compounds, for the reactants and products. Okay, so let's be careful about that. Now, let's do some practice about balanced chemical equations. Well, we have 2 examples here for you to try, and there's one basic guideline for us to follow when we try to balance a chemical equation. That is, you start from the most complicated molecule. Okay, let's take a look at this example. Cobalt oxide react with carbon, it generate cobalt metal and carbon dioxide. You can see the solid here, okay, and solid here and solid here. Apparently, right now it's not balanced because, for instance, you have 2 cobalt and you only have 1 cobalt. Okay, so we need to change the integer in front of it. No matter how much that is, you need to add the integer in front of those reactants or products to make sure that both sides have the same number of each atom. Okay, all right, each element. Now, how do we do it? Again, like I said, we start from the most complicated molecule. Well, it looks like to me, this one is the most complicated molecule, right? It has 2 cobalt and 3 oxygens. Cobalt, it's very easy. Well, you can just add 2 in front of it. But for oxygen, you have 3 oxygen here, and you have 2 oxygen here. Okay, so let's just try some numbers. Okay, so how about we put 2 here? Well, now if you can see, you have 4 oxygens here and you have 3 oxygen here. So between 4 and 3, you cannot put any integers here to balance the oxygen. So maybe you need to go back to this number and double check. Maybe 2 is not a good number, right? So let's just increase that to 3. So let's erase this and increase this to 3. Now, if this is a 3, then that means you have 3 times 2, 6 oxygen atoms. Now, you have 3 oxygens in 1 molecule of cobalt oxide. Now, if you want to balance oxygen, now you know that by multiply 3 oxygen by 2, then you will have a total 6 oxygens, right? So it looks like now oxygen is balanced. Okay, and then let's worry about the other the reagents, okay, or reactants or products. Now you have total 4 cobalt, okay, 2 times 2, 4 cobalt atoms, and you have only 1 cobalt atoms. Therefore, you can just go ahead and add 4 in front of cobalt to make the product side have 4 cobalt atoms. All right, now cobalt is balanced. Now the next one, the final element, is going to be carbon. Well, you have 3 carbons, okay, on the product side. Now you have only 1 carbon on the reactant side, so you just add 3, and then the equation will be balanced. Okay, so that means when you balance chemical equations, sometimes you do have to try different integers, okay? And you have to evaluate both sides back and forth multiple times. Sometimes, in order to make sure that both sides have the same number of atoms for each element, okay? Now, second equation, okay, as you can see that this is AQ. Well, this is the hydrochloric acid liquid. AQ means aqueous solution of hydrochloric acid. Okay, and here L, which means this is just going to be a liquid water. Now, how do we balance it? Well, if you want to start from the most complicated molecule, well, to me, maybe this one, water, it has 3 atoms, right? So you can start from water. Now, you have 2 hydrogens and 1 oxygen here. On the reactant side, you have 2 oxygen here. And let's see if you want to make sure that this water the product side has 2 water, 2 oxygen, then what we can do is we add a 2 in front of it, right? Okay, so now you have 2 oxygens on the product side, 2 oxygens on the reactant side. Oxygen is balanced so far. Now let's take a look at the hydrogen. Well, 2 times 2, you have total 4 hydrogen atoms on the product side, and you have only 1 hydrogen on the reactant side. Therefore, if you want to balance hydrogen only, there you just add 4 in front of it. Okay, all right, now both hydrogen and oxygen are balanced. Now the next element would be chlorine. You have 4 chlorine on the reactant side. Now you have only 2 chlorines on the product side. Therefore, in order to balance chlorine, you add 2 in front of Cl2. So now everything is balanced, and this is a balanced chemical equation for this particular reaction. We will do more practice in our class, and you go ahead and try those questions in homework and recommended practice, and you let me know if you have any questions.